Good morning.
Good morning.
So yesterday or in our last video we were talking about the fact that introducing this idea of circuits.
So now we're going to look at a circuit with resistors that are in series. So think series, one then the other. So
in a NBA series, you're playing one game after another until all the games are done.
Fantastic. That works. That works better than what I was thinking.
So how this works is our series resistor is just going to be our two other resistors added together.
Yeah. So if you have a 2 ohm and a 3 ohm resistor, we could represent that as a 5 ohm resistor. And so what we're just saying is if you had a circuit with those two resistors and another circuit with that 5 ohm resistor, they would actually have the same properties as far as current.
So I think of this as like miles that you run. If my resistor here says that I need to run 2 miles, and my resistor here says I need to run 3 miles, the total mileage I have to run is 5. This isn't going to work for our next one, but it works really well for resistors in series.
So using Ohm's law, V equals IR, we have 9 volts, we have 5 ohms, and what we get is a current in that circuit as 1.8 amps. And what that tells us is the current flowing from one resistor through another resistor is 1.8 amps.
So when we're talking about resistors in series, the current doesn't change, right?
Yeah, so the total current in that series circuit is the same as the current in the first resistor and the same as the current in the second resistor, same as the current in the third and the fourth, and so forth.
So what we're looking at is we're looking at our original 9-volt battery is producing that charge, it hits that resistor, and it's still 1.8 amps, right?
Right, and so you'll notice that what we've done now is we've taken that single resistor circuit of 5 ohms and we've gone back to our original. So now we have that 2 ohm resistor with 1.8 amps and that 3 ohm resistor with 1.8 amps.
Why is it meaningful to have to break it down like this?
Well, this is really helpful because in the long run, what we really want to know for every single resistor, for every single component in a circuit, we actually want to know its resistance, its current, and the potential across it.
So if we know each resistor, we can actually break it down for the potential, right?
Exactly. And so here, we're using Ohm's law again now, but for each individual resistor. So we're saying that 2 ohm resistor multiplied by 1.8 amps is going to give us a potential of 3.6 volts.
So wait, we use the current from the whole thing to determine the potential for each one?
Correct. And here's the important thing. If we look at the potential across that first one, 3.6 volts, and the potential across the second one, 5.4 volts, we'll notice that when you add those together, we get 9 volts, which is really, really important. Same thing, if you go from the third floor to the first floor, you better have walked down 3 flights of stairs.
So that's a really good way to check yourself is that if you have whatever your total potential, it should match your individual potentials added together.
Exactly. So what we just say is that for resistors in series, the potential difference across each has to be the total. So the change in potential for a series circuit is the change in potential across the first plus the change in potential across the second.